So today we're going to go over lesson 9.2, which is graphing parabolas. Parabolas come from an equation that has an x squared. Okay, an equation that has an x squared. So all the stuff we've been doing with factoring and with quadratic formula has, if I was to graph those equations, they would have a parabola. They would be a parabola. Okay, and so this is just visualizing all the work we've been doing with all the mathy stuff. Okay, so we're going to learn a couple new things today. So first we're going to start, this whole lesson is going to be over the standard form of the graph of a parabola. So the standard form, meaning what you would normally see, is y equals ax squared plus bx plus c, where a and b and c are numbers. So you might have y equals 2x squared plus 3x plus 5 or something like that, okay? The biggest thing that you're going to see that you're going to know it's a parabola is you're going to see that x squared, and that tells you, okay, this is going to look like a parabola, okay? You'll see what a parabola looks like here in just a minute. So the different letters, the A, the B, and the C, they tell us different things about how the parabola looks without having to graph it. It also helps us with graphing the parabola. So the first letter that we're going to talk about is A. The A value determines if the parabola opens up or down. It determines if the parabola opens up or down. If A is positive, it opens up. If A is negative, it opens down. Huh? Positive or negative, yes. The next thing that we can use the letters A, B, and C for is the axis of symmetry. So parabolas are symmetrical. They can be folded in half. I kind of feel like I need to show you what a parabola looks like.
Is it like a U?
Yeah. Yep. So here's our parabola. So this is what we're going to look like. So if the parabola opens up, it looks like that. If the parabola opens down, it looks like that. Okay. Parabolas are symmetrical, so we can fold them in half. Like a hot dog almost. And so the axis of symmetry is that line where they are symmetrical over. There is a formula for the axis of symmetry. It's x equals negative b over 2a. So it kind of reminds me of part of quadratic formula. It's like the very first part. So it's negative b over 2a. It's x equals because it's a vertical line. So remember, vertical lines are always going to be x equals a number. And so when I plug in b and a to that formula, it gives me the number that the line is equal to. And so this axis of symmetry splits the parabola in half. That is what the axis of symmetry does. It splits the parabola in half.
How long did that take you to learn how to spell parabola?
I don't know. I did it a lot. I've done lots of parabolas in my day.
Did you go to school for a math?
I did. Yeah.
How do you know you wanted to do math?
So the next, oh, it is pretty. The next thing that we can use A, B, and C for is the vertex. So the vertex,
Middle, where it meets.
Yep, y'all are right. It's this little point where it's at the top or the bottom, depending on whether it's opening up or down. So it's where I put that little pink star. That is the vertex. It's the turning point of the parabola. Yes, ma'am.
But I thought vertexes are only like connecting points.
Vertexes have lots of different meanings. Yeah. So this is the parabola vertex.
Okay, so there's a different vertex for every
Like angles, yeah. Yeah, different. And so in order to figure out the point that vertex is at, like on a graph, we can use the axis of symmetry. So it's a point, so it's like x comma y. And the x value is the axis of symmetry. So whatever number I have here comes right here. And then the y value, we're going to write this down and then we're going to talk about what it is.
Wait, so whatever x is
Mhm.
from that formula,
Yep.
whatever
Yep.
like blank equals,
Yep.
you write that.
As the x value of your vertex.
Okay.
So your vertex is going to be a point like x comma y. And so the x value will be the axis of symmetry. The y value is f of the axis of symmetry. So let's kind of talk about what that means because that looks weird. So think of like f of x, where I plug x into the equation. This is me plugging the axis of symmetry into the equation. So all this means is to plug the axis of symmetry, so whatever that number is, into the function. Now, this is all just information right now. We're going to apply it here in a few minutes and it'll make more sense.
Does f have a value?
Yes. No. F is the function, so the equation.
So you just have 2 points and they're both AOS?
No.
Like the same?
F of AOS will have a value. Yes.
Oh, okay.
So I will pull the AOS down, whatever it is. Let's say that the axis of symmetry is x equals 5. I will pull 5 down. That will be my x value. And then I will take that 5 and I will plug it back into my equation to get my y value for my vertex. Okay? And then the last one is the y-intercept. So that's where the graph crosses the y-axis. And that is also a point. The point is 0, comma, C. So the letter C.
This is a
Wait,
lot
Miss
to
Adams, can you
memorize.
unlock the lesson on Canvas? Can you get a second?
Mm-hmm.
Wait, what's O and C?
Okay, so here I have example number 1. So I have my equation in standard form, okay? Y equals 2x squared plus 4x minus 1. I first like to write what my A, B, and C are.
Does it have to be the exact order?
Yes, it will always be in that order. So my A value is the number in front of the x squared, so that's 2. My B value is the number in front of the x, so that's 4. And my C value is the number at the end, so that's -1. The sign does come with it. So if it's positive, we don't write the positive sign. But if it's negative, that sign comes with it.
So what is he facing up since 2 is positive?
Mm-hmm. So 2 is positive, so yep, that does mean that this opens up. Okay. The first thing I'm going to find is my axis of symmetry. So my axis of symmetry equation is x equals -b over 2a. So I'm going to say -4 over 2 times 2. Are we okay with that so far? Yeah. So that's -4 over 4, which is what? -1. I just plugged it into that formula, -b over 2a. Yep. So we do have to know this formula, -b over 2a. And then we just plug the a and the b into that formula. So that means that my axis of symmetry is at x equals -1.
Wait, so that means like they'll meet at -1?
Yep. So I'm going to actually go ahead and graph that on my my coordinate graph. So I'm going to go over to where x equals -1. X equals -1 right here. Oh, that is positive. Thank you. X equals -1 right here. So that means that my axis of symmetry goes straight down. And I'm going to label it AOS so that I know that's what it is.
Do you not put the dot there?
No. You can. It's fine. But you don't have to. It's not going to be, it's not, we don't know. We know that our vertex is going to be on that line, but we don't know where on that line. So.
So it's fine if I put a dot there.
It's okay, yeah. But just know that that dot might not end up being on your parabola. Yeah. Okay, so the next thing we're going to find is the vertex. We're just going to go in order. So the vertex is a point. So it's like x comma y. The x value is the same as the number from my axis of symmetry, so -1. So I can automatically put that there. To find the y value, I plug -1 back into my original equation.
Oh, that's
So I'm going to have y equals 2 parentheses, negative 1 squared, plus 4 parentheses, negative 1 minus 1. I know.
So now you took your x's and plugged them into the whole equation.
Yep. Took my x, plugged it into the whole equation. So negative 1 squared is positive 1, and positive 1 times 2 is 2. 4 times negative 1 is negative 4, and then I have that minus 1.
Wait, what?
I just was doing these.
Wait, why is that?
So
So,
negative 1 squared is positive 1,
oh.
right? Positive 1 times 2 is 2. And then positive 4 times negative 1 is negative 4. And then I have that negative
Why
1.
is the 4 positive? Wait, what?
This positive 4
Wait, why is
times
the
this
one
negative
positive?
1.
Oh.
Negative 1 squared?
Negative,
Negative
Oh.
1 times sorry. Negative 1.
So does
Yeah,
that just
yeah.
mean plug back into the equation?
yep.
I think there's something.
Okay. 2 minus 4 is negative 2. Minus 1,
Negative 3.
negative 3. So that is my y value, negative 3. So that means my vertex is at negative 1, negative 1, 2, 3, right here. So go ahead and make a point for your vertex. Okay, your vertex should always be on your axis of symmetry. So if you've already done your axis of symmetry, your vertex will be somewhere along that line.
Oh, because
And do I put a dot
Your-
the
there?
answer of your axis of symmetry is.
Yes, exactly.
Do I put a dot there?
Yes, you do put a dot there.
You put your vertex where the point was.
Yes.
Should I say like vertex?
No, just put a dot. Just a dot.
So where it crosses over the y-intercept, that's like the angle of your line?
Uh-huh. So then the y-intercept comes from, the y-intercept is also going to be a point. Y-intercepts are always 0, comma, a number. Okay? Because it's where the x-axis is at 0. The number for our for our y-intercept is the c value from our a, b, and c. So our c value is negative 1. So this is 0, comma, negative 1. So that means that there's a point at 0, comma, negative 1 right here. That's my y-intercept.
Oh, and then you can just make it symmetry.
Yep.
It's the c value.
It's the c number.
How do you know like how far out the arrow goes? Like when you're like making it like
I go all the way to the top.
so like
Oh, you just kind of guesstimate. Yeah. So this guy is my vertex. This guy is my y-intercept, right? Now, my axis of symmetry is what's going to help me find a point on the other side, okay? If my y-intercept is 1 step away from my axis of symmetry, then there's going to be another point 1 step away on the other side like that.
Wait, what?
Imagine folding it in half.
Yeah, like if I fold it in half, there, wherever that y-intercept is, there's going to be another point on the other side at that same spot. Does that make sense?
Don't you see it?
Okay.
Cubes away, is it? I just
And so that gives me 3 points. I need 3 points.
Wait, I don't understand how you got the y-intercept is -1.
From my c value.
So c.
So my y-intercept is always going to be 0, comma, c.
Oh, that's what it is.
So no math involved, just pulling that c value. Yep. Okay, and so I know that it opens up. I have these 3 points. I have a pretty good idea of what a parabola looks like. I know the shape. So I'm just going to trace going through those points. It does not have to be perfect. That wasn't very good. I used the axis of symmetry.
Which is -1.
Yeah. So this y-intercept point is one step away from the axis of symmetry. So I did one step away on the other side to get me another point so that I could have 3. Does that make sense? Then let's look at example number 2. So for example number 2, the first thing I'm going to do is write down my A, B, and C values. So my A value is what?
1.
Okay. My B value,
6. Negative.
-6. The sign goes with it. And then my C value?
2.
2. Perfect. Okay. My axis of symmetry is always going to be x equals a number. We get that from x equals -b over 2a.
So it would be +6.
Good. So when I plug it in, it's -6 over 2 times 1, which ends up being a +6 over 2.
So 3.
Good, which is 3.
So can I just think of negative b as the opposite?
Yes, you totally can. So that means I'm going to go over to 3, and I'm going to draw my axis of symmetry. Axis of symmetry, always a vertical line. Okay, so the vertex is a point, so it's x comma y. The x value is the number from my axis of symmetry, which is 3. The y value comes from plugging that 3 in to f of x. So we're going to say that f of x equals, you could even say y equals if that makes more sense to you because it's the y value. Y equals 3 squared. So I'm still putting 3 in parentheses because I'm substituting. If that 3 was negative, I would want it to be in parentheses when I square it. So 3 squared minus 6 times 3 plus 2. Yes, ma'am.
I'm confused. What happened to the f of x? Is that literally the same y?
Mm-hmm.
So that's why you put y.
Yeah, you could put either one.
Made it a negative, because one was a x squared, you made it a negative because of -6, right? You didn't.
Right, right. So 3 squared is what? 9. And then -6 times 3. Good, -18, and then plus 2. Okay, so 9 minus 18, -9, and -9 plus 2. Good, -7. Okay, -7. So that is where my vertex is. So I'm going to go over to 3, and I'm going to go down 1, 2, 3, 4, 5, 6, 7, all the way at the bottom. There is my vertex. So then my y-intercept is also a point, and it's always going to be 0, comma, c. So this is going to be 0, comma what? 2 from my c value. So I'm going to go over 0, up 2, and there's my y-intercept.
Is it half times or half of 4?
Yes. Okay, so this is what I have so far on my graph. I need 3 points. Okay, so if you're confused on how I'm getting that third point, make sure you watch the board. Okay, I need 3 points. This y-intercept is 1, 2, 3 steps away from the axis of symmetry. So I'm going to go 1, 2, 3 steps away on the other side to get my third point. Does that make sense? Yep.
Okay, this is not too bad.
It's not too bad. I want you guys to turn the page, and I want you to try number 1 on the next page all by yourself. The whole thing, the whole shebang. So number 1 we did okay with. Checking our answers. For number 2, A is -4, B is -4, C is 3. So my axis of symmetry is x equals something. So we have -4 over 2 times -4. So that's 4 over -8. So -1/2. Did y'all get -1/2? For the axis of symmetry?
Yes.
Yeah. So that means I'm just going over a half. So it's like in between 0 and 1.
Are there fractions on the homework?
Probably, possibly. I wouldn't think there's anything more than a half or like in between. Like you could get like
There's a -6 over -4. How do you do that?
-6 over -6 over 4 is 1.5. So I would just change it to a decimal so that you know you're going over. So there's not going to be anything smaller than a half, like where you have to go halfway. But it could be like 3 halves or something like that, where like, but then just change it to a decimal or a mixed number. So that means my vertex is going to be -1/2 something, but that does make the plugging in part a little bit yucky.
What is 1/2 squared?
1/4. So we have 4
Wow.
-1. Yeah. Squared plus, no, minus 4
And
times
is that like
-1/2.
-4 times 4?
Hmm?
Is that, so like what would 1/4 times?
So I have -4 times 1 over 4 minus a plus. That'd be 4 over 2 plus 3.
4 times 2.
Because you put 4 over 1 and
4 over 1, yep. And so then same thing here, 4 over 1.
How do you do the fractions?
-4 over 1 times -1 over 2.
do you cross multiply?
No, multiply across. So that's how I got the 4 over the 2 here.
Wait.
You gotta know how to do fractions.
Wait, but like, why did you do 4 over 1?
So I can multiply straight across.
Okay, so then you did 4 over 4.
Which was 1.
Which is 1. Then this is 2, 3. Yep,
So it's -1 plus 2 plus 3.
yep,
So it's 4.
yep.
That's odd.
So that means we're going over 1/2, up 1, 2, 3, 4. There's my vertex. Are we opening up or down?
Down.
Down. How do we know that?
Because A is negative.
Good.
You got it.
Okay, and then where's my y-intercept at?
0, 3.
Good, 0, 3. So that means I'm going over 0, up 1, 2, 3. Okay, this one's really narrow. So if that's there, then that means there's another point right here.
What?
Super close. Because it's only 1/2 away, so then it's 1/2 away.
Why did you put that?
Okay,
That's not stupid.
so then this one's really narrow. Kind of helps you to see the shape of the parabola. Try number 3, and then we'll be done. How did we do?
This is easy.
Good? Okay, you are allowed to get 0. That is allowed. There are zeros on the graph. Totally fine, okay? So your quiz next time will be over 9.1, not the calculated part that we didn't do, just 9.1a and 9.2. It should have been 9.4, but it was 9.2 because I taught the wrong one first, but it's fine, okay?
So what homework do we have?
So your homework is over 9.2. I'll give you guys a few minutes to pull that up, and then I will pull some extra practice problems over quadratic formula that we can look at.